You probably don't always want to get all the rows from a database table, so let's take a look at a few more capabilities of LINQ. Although this certainly won't be exhaustive, and remember there's a querying course that I pointed to earlier. As we look at the very first filter example, I want to be sure that you understand that EF Core will protect you by default from SQL injection attacks. So we'll take a quick look at that, and then we'll look at some more filtering features. Again, I've made another change to the program file. Rather than instantiating the pub context in each of the demo methods, I'm instantiating it when the program class starts up. And this is fine for the purposes of this demo and allows for cleaner methods so you can focus on the primary lessons. Here's a new method called query filters. Instead of just getting all the authors, now I'm filtering on the authors whose first name is Josie, and I'm using the LINQ where method, which takes a lambda expression as its parameter. Notice how IntelliSense is helping me out here when I'm typing the code. This is similar to the lambda expression you saw with include in the last module. It begins with an input parameter, and I've named that S to just make sure you see that the name of that variable is totally random. The input parameter represents the author type that I'm querying. And after the input parameter is a lambda operator token, which is the arrow composed of an equal sign and a greater than sign. And then the expression that needs to be evaluated using the input parameter. So this lambda expression will look at the first name property of authors and find those where the value is Josie. So that's how I'm expressing the filter, and then I'm executing the query with LINQ toList method that you've seen already. And the resulting list of authors only contains one author, the one that's named Josie. Parameterization is really important for security when sending queries and commands to a database in order to prevent SQL injection attacks. So I want to be sure you understand EF Core's behavior for when it does and when it doesn't create parameterized queries. If you want to learn more about SQL injection attacks, check out Troy Hunt's Ethical Hacking SQL Injection course here on Pluralsight. In my query, I'm hard-coding the search value, Josie, and you can see in the profiler that it's also hard-coded into the SQL that EF Core sent to the database. Because it was hard-coded into the LINQ query, EF Core sees that the value didn't just randomly come from some data entry somewhere, and it's safe. So it just passes along that hard-coded value into the SQL. However, it's very common in your apps to have a variable coming in to specify a filter, and quite often that's some data that came in from somewhere such as a user typing into a form or query parameters from a URL. Then the value won't be hard-coded, and it will be part of the LINQ expression by way of a variable. Any time EF Core sees a variable being used in a LINQ query, it will always build a parameterized query to send to the database, as you can see in this code example. Here I'm creating a variable, name, with the value Josie. In a real app, that variable might be getting passed into the method. When I use the variable in my where expression, EF Core will parameterize the query. That's the default behavior, so you can be confident that EF Core has your security in mind. Let's see that in action. I've modified the method to add a name variable with the value Josie, and in the where predicate, I've changed that filter on first name, so now it's equal to the name variable. And when I run this again, you can see a very different SQL command was passed to the database, where this name0 parameter is defined as an nvarchar 4000, and that's the default for the SQL Server provider when it's dealing with strings. And its value is Josie. Then that parameter is used here in the actual select command. That is certainly comforting. Let's take a look at a few more ways to filter when you're building queries with EF Core. Another way to filter queries in EF Core is to look for partial matches. And there are two ways to achieve this. One is to write like queries the way you can write them in SQL, surrounded by wildcards. You could achieve the same kind of filtering with the LINQ contains method, But using the like method might be more natural for some developers who are used to writing their own T-SQL. And in fact, the contains method translates into a like SQL query anyway. The function's like method takes the property you're searching for as the first parameter, and then the expression that you're searching for as the second. To use the contains method, you append that to the property you want to search on, and then passing into the contains method the string you want to search for. Here's an example where I'm using the like method to query for authors whose last name starts with a capital L. And this feature is possible thanks to the EF functions, which are built right into EF Core. So in this case, for that second parameter, I'll just build a string that's a capital L followed by the %symbol wildcard for anything that comes after L. When I run the method and look at the SQL in the log, there's the like operator using the T-SQL syntax. And notice that because I hard-coded that search value, it's directly in the SQL command. But if I pull the value into a variable, as I've done here now with the variable named filter, and then use that variable in the LINQ query, again, the SQL is parameterized and safe from an injection attack. Another common filter in our apps is when we know the key value of an object and want to search for that. While you could use a where method again and filter on the author ID property, there's another method to be aware of: find. Retrieving an entity by its key is find's only job. You can't use it for anything else. It will create the appropriate query to send to the database. And find isn't a LINQ method, it's a dbset method that will execute right away. And in fact, if you try to append a LINQ execution method, that won't compile. Find expects only one result, and it constructs a select top one query to locate the first result in the database. The query it builds is also parameterized. The find method also has a great benefit in that if the object with that key is already in memory and being tracked by the context, EF Core won't waste its time creating and executing a query on the database. It'll just return the in-memory object that it's already tracking. There's another interesting type of filtering that's especially handy for websites, and it's referred to as paging. For example, you may have a website where you're showing 10 rows of data on a page. LINQ supports paging with skip and take methods. You can retrieve the first 10 rows and then the next 10, etc. If someone wants to go directly to page 4, you can skip 30 and take the next 10. In most cases, this will give you much better performance than just bringing back every row into memory and letting the client page through them. In order to demonstrate this to you, I did need to have a few more authors in my database. So I created and already ran this method called add some more authors in my app that added 5 more authors. And because I am a proud daughter, I do want to point out my mom, Rhoda Lerman, who wrote many wonderful novels and some nonfiction as well. Her first novel that she wrote at age 30 was even submitted by her publisher Doubleday for a Pulitzer Prize. And there's 3 other authors here. Don and Jim both work at Pluralsight, and they've published fiction. And Stephen is another Pluralsight author who, like many of us, is also a technical book author. Now with some more authors in my database, I'll show you my other new method, skip and take authors, in order to page through them. I've set this up in a way that's typical for an application, although I'm using small groups, only 2 at a time. Then I iterate from 0 to 4, incrementing 1 at a time. Then for each iteration, I query the authors and skip the current group, which is calculated by the group size of 2 and the iteration. So the first time I'll skip 0, and the next time I'll skip 2. And each time I'll take the next 2 rows from the table, and then write the names of the authors on each iteration out to the console window. And each time the LINQ query is executed, EF Core knows how to translate it. EF Core and the SQL Server provider translate the skip and take queries into T-SQL using offset and fetch next. That's T-SQL syntax I would have had to Google anytime I wanted to use it, so thank you, EF Core. Here's one of those SQL statements where the skip parameter was 4 and the take parameter was 2. And here's the output where you can see the results of my iteration through all of the queries. Apparently, I incremented beyond the number of authors in my table, since Group 3 only had one last author and Group 4 had none at all. Sorting is fairly easy in EF Core queries, but there are a few things that aren't so obvious, and I wanted to be sure you're aware of them. The link method used for sorting is order by. It takes a lambda expression of the property you want to sort by. Here's a query where I'm sorting the authors by their last name, and then writing out the last name and first name of each author to the console. That works as expected. Now, although the first names of the 3 Lerman authors already happen to be in alphabetical order, let's modify the query to sort by last name and then by first name. And here is how any intelligent person would guess to do that with LINQ. Order by last name, and then order by first name. But look closely at what happened. The last names are no longer sorted, but the first names are Don, Jim, Josie, Julie, etc. The authors are all sorted by the first name. That's because if you have multiple order by methods in your LINQ expression, LINQ will ignore all but the last one. What we need to use here is the LINQ then by method. Now I have order by last name, then by first name. And if you look at the output, it's working correctly. You can also do descending sorts with the order by descending and, if needed, then by descending methods. I'll apply both of them to my query, and I'll order by descending last name, then by descending first name. But you can, of course, mix and match these along with the order by and then by as needed. And here in the results, you can see the last names are in reverse order, and the 3 Lermans also have their first names in descending order. Keep in mind that you can combine LINQ methods as well. Here's an example where I'm using where to do a filter and order by descending to do some sorting on the same query.